perfect squares. My smallest one is 1, kind of not useful. My next smallest square would be 2 times 2, which would be 4. Then we'd have 3 times 3, which would give us 9. 4 times 4, 16. Then we're going to have 25, because it's 5 times 5. 6 times 6, we should have 36. 7 times 7, 49. 8 times 8, 64. That's usually the biggest one we have to have memorized. I'm going to keep going a little bit further. So 9 times 9 would be 81. 10 times 10, that's a hard one. That's a hundo. I'm going to stop at 11 times 11 because that's 121. Now remember, all of these are figure outable. If you get to the test and you want to write those at the top, cool. You just got to go in your calculator, 2 times 2, 3 times 3, 4 times 4, and you have all these numbers, so you don't necessarily have to memorize. It's nice to have some of these memorized. It's going to help you simplify these, but you don't need to know all of them. All right, so something's important with perfect squares, that we can't have a perfect square underneath the square root or a factor of a perfect square under the square root. Second rule, no fractions underneath the radical. So you can't have a radical symbol and then a fraction in it. Well, I'll show you that in a second. But more importantly is C. No radicals are in the denominator. In fact, I would say C you can put in place of B. You can't have a denominator underneath a radical. So if you have a fraction, you can't have a radical over that denominator, whether it's isolated or it's the whole thing, and we'll see both those examples in a second. So let's first follow those rules and say square root of 64 is not simplified. Yes? It would be 8. It'd be 8 because there's a perfect square. 64 is a perfect square. You could rewrite this. Square root of 64 is the same thing as square root of 8 squared. Now, the important thing is to understand that squared and square roots cancel each other out. It's like multiplication and division, that they cancel each other out. So if you see that square root and that square, they cancel out, and that just results in 8. In other words, 8 times 8 must equal 64. So if I have a square root, that's easy. You can put it in your calculator and it works. If you plug in square root of 64, it works. If you plug in square root of 32 in your calculator, it doesn't work, but it's not simplified. 32 is not a perfect square, but it's not simplified. Does anyone know why square root of 32 is not simplified? Because it's not a perfect square. Well, square root of 3 isn't a perfect square. So let's keep that line of thought. Square root of 3 is not a perfect square, but that is fully simplified. That's done. That's done because of the first rule. The first rule says no perfect square factors. You're looking for factors that are perfect squares. So when I look at 32, you need to look at your list of perfect squares and ask yourself, is there a perfect square that goes into 32? So does 4 go into 32? Yes, I'm going to put a pin in that real quick. Is there a bigger perfect square that goes into 32? 16 goes into it. That's important for us to know. 16 goes into 32. So instead of looking at this as 32, I'm going to look at this as the square root of 16 times 2. 16 times 2 is 32. Well, we have to know a special rule with square roots. If you have a square root and all multiplications underneath the square root, you can spread it apart. You can rewrite this now as square root of 16 times square root of 2. And what is the square root of 16? 4. So this equals 4 times the square root of 2, which we usually just write as 4 square root of 2. Just like if I have 2x, I don't write it as 2 times x. I just write it as 2x. 4 times square root of 2, I'm just going to write it as 4 square root of 2. We don't need that multiplication because we know it's tied through multiplication. Now, let's play devil's advocate real quick here. And this is going to happen to you. You're going to go, oh, 32 divided by 4. 4 is a perfect square. It goes into 32. So you might go, this is another method that you might have done. You might have said, oh, that equals the square root of 4. Does 4 go into 32? How many times? 8 times. So it does go into it. Now we could break it apart into square root of 4 times square root of 8, which would give me 2 square root of 8. This leads me to my next thing. Whenever you have something under square root, you should double check that a perfect square doesn't go into it. Is there a perfect square that goes into 8? 4 goes into it again, so I have to do it again. So if I went down the 4 route, I have to do it twice. That's going to give me a calculator flying across the room. Still works. That will give me 2 times the square root of 4 times the square root of 2. Square root of 4 is 2. 2 times 2, that would be 4 square root of 2. I know I kind of hurried it up here. I just want to show you that if you pick the wrong one, you're increasing the amount of steps you have to do. So I would take that extra second in my calculator, because you guys have calculators on your desk, right? If you're not sure, just 32 divided by 4, 32 divided by 9, 32 divided by 16. Find that number. Once you get to the halfway point, you don't have to try anymore, because obviously 36 can't go into it. So it's just a couple clicks of your button to find out that this method is way better than picking the wrong one. That leads me to 216. 216 is a big number. Not guaranteed that it's simplified or simplifiable, but if you see a big number like that, you should have your calculator out and you should be checking, do perfect squares go into this? Is there a perfect square that goes into 216? Does 4 go into it? I would check that. Okay, 4 goes into it. Does 9 go into it? Yes, it does. So 9 would be a better choice. Does 16 go into it? I like all the lazy people who have calculators and none are doing anything. No? Okay, does 36 go into it? If you need your phone calculator, just do work, guys. Don't just sit there and be lazy. Does 36 go into it?
Yes.
36 is the biggest one that's going to go into it. So if you were the one that stopped at 4, this is a long problem. 36 is going to be really, really quick because I just have to do it once. So I'm going to take a second and I'm going to find the biggest thing that goes into it. 36 goes into it. How many times does 36 go into 216? 6 times. Now, I know I'm probably good because 6 doesn't have a perfect square that goes into it. 4 doesn't go into it, so 6 is good. So now we break it apart into square root of 36 times the square root of 6. Square root of 36 is 6, so I have 6 times square root of 6, which I just write as 6 square root of 6. So if you give me an answer on a test that square root of 216 is not correct because it's not simplified. You have to know how to simplify these. All right, our next one. What happens if I square a square root? They cancel out. So if I have square root of 14 squared, it just equals 14. So that just equals 14. They just legit cancel each other out. They're opposites of each other. Multiplication, division. Square roots, squares. You should have a parenthesis around here. Now here's the problem with number 5. You have to square it, which means everything gets multiplied twice. So this is 5 square root of 7 times 5 square root of 7. So I have to repeat that multiplication. Now with that repeated multiplication, everything's tied together through multiplication, so I can get rid of those parentheses. I can tie everything together, so really I have 5 times square root of 7 times 5 times square root of 7. Now stay with me real quick. If I did 2 times 3 times 4, would that be any different than 4 times 3 times 2? No. Multiplication can be done in any order. It's hang on, I got words. Cumulative. Nope. Commutative, thank you. I had the ends mixed up in my head. All right, so that means I can move numbers around. So I'm going to move things that are close to each other. Like if I had x's, I'd move the x's together. I'll move numbers that don't have square roots in them to numbers that don't have square roots in them. So I'm going to move the 5s together. I'll 5 times 5. And I'll move together the square root of 7 times square root of 7. Now note that square root of 7 times square root of 7 is square root of 7 squared. So what would square root of 7 times square root of 7 equal?
7.
It would equal 7. So if you've ever seen a square root multiplied by itself, you just get rid of the square root because you are getting squared. So square root of 7 times square root of 7 is just 7. So now we have 5 times 5, which is 25, times 7, 170. You could plug this in your calculator, right? Do I ever judge you because you use a calculator? Have I ever told anyone you can't use a calculator on a problem? No. In fact, I tell you, if you do it in your head, do it in your calculator just to double check your work. So we should have that equals 175. I'm going to pause right there. Were there any questions on any of those first 5 questions? Yes?
On the last one, couldn't you just square each of the numbers in the parentheses?
Yes.
Would that be like a lot easier?
So yes and no. So what you're saying is basically, I recognize that these are multiplications, so that's 5 squared times square root of 7 squared, right? I'm totally on board with that. But you have to remember the rule that it's multiplication. Because people that do that a lot, they'll do the same thing. Let's say I had x plus 5 squared. All of a sudden, they'll apply that exact same rule, and they'll say that equals x squared plus 5 squared, which is wrong. Because if it's attached by addition, it's actually x plus 5 times x plus 5. So if you understand the rule only applies if it's all multiplications getting squared, then yeah, nice shortcut. But if you're uncertain, you know you can always expand it like this. Kind of up to you. Yeah?
If they're different numbers, do we just like multiply the numbers and put the square roots in?
Yeah, we're going to do that next, right? Yeah, so we'll probably do a 6 times 12 in a second. Other questions? I thought I saw a hand over here. Okay, we got to know those rules to move on. Are we good? Okay, next rule looks almost identical. I have 2 things being multiplied, which means I can change the multiplication order. So instead of the order they give me, I'm going to change this to 3 times 5 times square root of 6 times square root of 12. Now, Mason brought up the fact that I can do something with this. Look above. Do you see how in number 3 I broke apart the 36 and the 6? Well, that means I can go the opposite direction as well. I can smoosh these together. So multiplication with square roots, I can put it all under one big. So if I see a multiplication with square roots, I'm picturing one big square root. In other words, well, I'll do the 3 times 5, which is 15, times, underneath the square root, I'll have 6 times 12, which is going to give me 15 times the square root of 72, unless my math is completely wrong. Yeah?
On my page, there's parentheses in that one. Does that change anything?
There should be a parentheses. It doesn't matter. I probably just did that to let you guys know that parentheses can disappear if they're all multiplication. But no, it doesn't change anything. But am I done? I did all that nice work multiplying. I don't want to lose points because there's a perfect square that goes into 72. Does anyone? Actually, there's a few of them. Does anyone know the biggest square root? So take a second, find the biggest square root that goes into 72. Yeah. 36 goes into it. So we can then rewrite this as 15 times the square root of 36 times the square root of 2. So I'm going to start doing that where I don't write everything out. I'll show you what I was doing in my head because I was picturing this as the square root of 36 times 2. I'll just break it apart in my head to make it easier. So I broke apart square root of 72 to square root of 36 times square root of 2. Square root of 36 is 6. I have 15 times 6 times the square root of 2. 15 times 6 is 60 plus 30, which is going to be 90. Square root of 2. I do not need to see all of these individual steps. Like Luke, you brought up the fact that I could have just did this. That saves a whole bunch of this work, right? So I don't need to see every single step, but I should see your thought process at the very least. Questions on number 6? Okay, then the last thing we have to talk about is what happens if I have fractions. The one rule is you cannot have a square root in the denominator. So if I look here, I have a denominator and a square root in it. Can't have that. I need to turn that into something that doesn't have a square root in it. Does anyone remember how to get rid of a square root in a denominator? Tito? Maybe?
I was going to say square it.
Square it?
Square it.
Kind of. you're on the right path, because if I square it, I get rid of it, right? We're doing something like that. Yeah.
Is it multiply both sides by square root of 2?
Yeah, I'm going to say the top and bottom. Yeah. So the same idea, because you want to get rid of that square, so I want to basically square it. But we can't just do this. And the reason why we can't just do that is because it changes the number. If you owe me $20 and I'm like, well, if I square it, you owe me $400. Are you okay with that? No. So we can't just square it, but we have to keep that same idea. The same idea says, what if I multiply the bottom by square root of 2? That's squaring it. But to keep it balanced, I have to multiply the top by square root of 2 as well. And that's because if I have a fraction with the same thing on top and bottom, what does that equal? It equals 1. Now, Tito, you owe me $20. If I multiply by that 1, you still owe me $20. If I multiply 20 by square root of 2 over square root of 2, it equals 20. So this stays the same, it just changes appearance a little bit. In the fact that we now have square root of 2 times square root of 2, which equals, square root of 2 times square root of 2, is that 4?
No, it's 2.
It's 2. It'd be square root of 4, which turns to 2. So that, the square root's gone, and it just moves to the top. So in essence, I'm just taking that square root from the denominator and moving it up top. All right, square root of 16 over 28. Now, like I said, the only rule you have to keep track of is you can't have a square root over a denominator. Is 28 a denominator?
No.
Yes, it is. And there's a big square root going over it, so we can't do that. The square root is not just in the numerator, it's also in the denominator. We're going to be able to break that apart. So don't write it down, but we could break this apart into square root of 16 over square root of 28. Now, the reason I'm not going to do that as the first step is because I'm going to recognize that I can simplify this fraction first. 4 over 7 would be correct, because I'm going to recognize that 4 goes into 16 and 4 goes into 28. So we're working within the square root for just a second. I'm saying I can divide that by 4. I can divide that by 4. That's going to equal the square root of 4 over 7. Now, just like multiplication, I can spread it apart. I can spread it apart over division. So I'm going to rewrite this as square root of 4 over square root of 7. That's my whole problem, though, is that square root in the denominator. Can someone raise your hand and tell me what I should do in my next step to get rid of that square root? Will?
Times square root of 7.
On top and bottom. Both sides usually, I get it, but clear image is top and bottom, just so you don't think that we have an equal sign. So I'll multiply the bottom by square root of 7. I'll multiply the top by square root of 7. The top is going to turn into square root of 4 times 7. All over. In fact, let's stop for a second. Let's leave this as square root of 4 times square root of 7. Let's not do that multiplication right off the bat. The bottom is 7. Can anyone tell me why I stopped? I was going to push them together, and I decided last second that I should stop. I shouldn't push them together. Yeah. 4 is already a perfect square. If I push it in there, I'll have to pull it back out. It's already a perfect square. What's the square root of 4? 2. So I'm just going to, at this stage, I'm going to write this as square root of 4 is 2 square root of 7 divided by 7. I'm going to tell you this last one, there's a lot of different ways to do this. One way you could do is you could turn this into one big square root, simplify the fraction, and then go from there. I'm going to do what most people would do. Most people would say I have a square root in the denominator, let's multiply the top and bottom by it. If you did something else different, I see a lot of us started it, or some of us started it. If you started a different way, see if your way works. But I'm going to go ahead and I'm going to say, let's get rid of the square root in the denominator, multiply the top and bottom by square root of 24. That's going to then give me 4 times, I'm going to cheat this real quick, just skipping kind of step that this is 3 times 24, all under the same square root. Because multiplication, I put it all under one square root. Square root of 24, square root of 24, well, that's just going to equal 24. All right, continuing on, we'll have 4 times the square root of 72 all over 24. Is square root of 72 simplified?
Yes. Wait, no.
I think we just did this right above it, right? Didn't we just do, what is 70, how do I rewrite square root of 72?
Square root of 36 times square root of
36 times the square root of 2, which turns into 6 square root of 2, okay? So I'm going to go ahead, I'm going to skip that step because we did it right above. So I'll have 4 times 6 times the square root of 2. Once again, if you're not sure, look above because we did that exact same step above. That's why I have that. 4 times 6, that's 24.
Wait, 4 times 6.
Yeah, 4 times 6. Because this 6 came from when I broke apart that square root of 72. If you look right above it, the square root of 72 breaks down into 6 square root of 2. So I skipped a couple steps. So we have 24 over 24, which will cancel out because our numerator is all multiplication. So this just breaks down to square root of 2. This is why you lose points if you don't simplify. I don't know about you, but this is a lot harder to deal with than square root of 2. Oh, I want to stop. I forgot to mention something. I'm going to circle something. Why didn't I cancel out those 2 7s?
One's not 7 to square root.
One's not 7. One isn't 7. If you plug in square root of 7 in your calculator, it doesn't come out to 7. They're not equal to each other. They're using the same number, but they are not equal to each other. All right, questions on any of those steps? Okay, you'll notice I am putting a lot of pressure on you, actually. Look at the very last page of your homework. Flip it all the way to the last page of this homework. Not the next homework. I'm sorry. Just page, stop, of this homework. So page 4. What's on page 4? The answers. You don't have to go online. There's no work online. Either you get the answer or you don't get the answer. And you need to show me work. If there's problems that just have answers, I'm going to assume you just copied it off the back and you won't get credit for it. So, yeah. So if you think it's wrong, if you get an answer and it's different than that, just put a star by it. I don't have work to support it, so put a star or a question mark. I'll answer it in class. We'll go through it together. We're not going to get credit if we put question marks on everything, but we can always redo it and get the points back that way. So don't cheat on this one.